All right, everybody, welcome to the video for lesson number 6, proofs involving isosceles triangles. The first question in homework is not even a proof question. It's just, do you know what isosceles triangles tell you? So it says in the accompanying diagram, we have this line BCD. It says AC and BC are congruent, so let's label that on my picture. Hey, that tells me that two angles are the same. These two angles are the same. Right away, I know that because it's isosceles. It then tells us that the exterior angle is 136. And it wants us to find angle B. We can do this two ways. We can use the exterior angle theorem by saying the two non-adjacent angles inside the triangle add up to 136. Or how a lot of you probably did it, which was 180 minus 136 gives you 44. That's this angle. And if I do 180 minus 44, guess what I'm going to get? I'm going to get 136. So 136 then gets split evenly between the two base angles. And that makes each one of them 68. So angle A is 68 and angle B is 68. They want angle B, so we chose choice 2. That's something I could have asked you to do way back in Unit 1. All right, let's talk proof. So the first proof here tells us some stuff. It tells AE is parallel to BD. It says B is the midpoint of AC, and angles E and D are the same. Well, if AE is parallel to BD, that means I should have something, either alternate interior or corresponding angles. I don't really see a good Z shape here that I can use. So what we're going to use here is alternate interior corresponding angles. So I'm going to call this angle 1, I'm going to call this angle 2. Right? Because those two lines are parallel, those are going to be congruent angles because they're both corresponding to each other. There's no vertical angles in this picture. I know it looks like it, but there's not an X there. That doesn't look like an X. And then it says B is the midpoint of AC, so BC and AB are the same, and angles E and D are the same. So that gives us an angle side proof. Now it wants us to prove CD is congruent to BE. This statement alone tells us it's a CP-CTC proof. So let's start building our proof. AE parallel to BD, that was given. What did that tell us? It told us angle 1 is congruent to angle 2 because they are corresponding angles. The next given was that B is the midpoint of AC. That was given. What did that tell you? That told us that BC was congruent to AB. And the reason we know that is a midpoint divides a segment into two congruent segments. And the last thing was just a given, angle E is congruent to angle D, given. All right. After I put all of that, I can say that triangle ABE is congruent to triangle BCD by angle side. Now, your first job is always prove the triangles are congruent. Now that I have the triangles are congruent, all of their corresponding pieces are congruent, meaning I can say that CD is congruent to BE by CPCTC. Corresponding parts of congruent triangles are congruent. All right, let's keep moving. Number 3 is another one of those non-proof questions. It's just asking you, can you do stuff here? So it says, in the following diagram, it is known that AB is congruent to AC. These are congruent to each other. It says angle BAC is 30. BAC is 30. That's this angle up here. If that's 30, without reading anything else, I know because of the triangle, there's 150 degrees left, meaning the remaining angles are each 75. It then says that angle EAC is 75, and it wants us to explain, not prove, explain why AE, let me grab my highlighter here, AE is parallel to BC. Well, if I draw this transversal line in, I'm hoping you see alternate interior angles. So we can say AE is parallel to BC because angle EAC is congruent to angle BCA, which makes them alternate interior angles. No bubbles, no proof here, just do you know what you're doing? Just do you know what you're doing? All right, let's go to last proof, number 4. Number 4 gives us a bunch of different givens and asks us to prove angle 1 is congruent to angle 2. As soon as I see that, I'm thinking CPCTC, meaning I have to prove the triangles are congruent. Now these triangles do have some overlap, so I'm going to highlight them. So here's one, and let me grab a different color here. We'll use yellow. So we see something right away, but let's talk about the givens first. So it says triangle ABC is isosceles, and it says AB is congruent to AC, meaning angle B and angle C are the base angles. So those two givens together, this together tells us those angles are congruent. It then tells us that AD bisects BC, so BD and CD are congruent. And then I should be able to see right away just by labeling that that's a side angle side proof. So let's build our proof. Triangle ABC is isosceles with AB congruent to AC. That's all given. That's actually going to tell us two different things. One of them is going to go directly to my answer, but one of them tells us about these angles. Angle B is congruent to angle C because the base angles of an isosceles triangle are congruent. Okay, simple. All right. It also tells us that AD bisects BC, that's given. And that told us that BD was congruent to CD because a bisector divides a segment into two congruent segments. Just that is enough information for me to prove the triangles are congruent. So I can say these triangles are congruent. I can say triangle ABD is congruent to triangle ACD by side, angle, side. Now where are your sides and angles coming from? Here's your angles. One of your sides came from this given bubble, right? AB was congruent to AC, and the other side was here. Now all that's great, but it's not done. I now know that the two triangles are the same, so that means all of their corresponding parts are the same, meaning angles 1 and angles 2 are the same by CPCTC. That's your homework assignment. Hopefully that helped you get through it. Hopefully you're doing a lot of this yourself. You're not just watching the video and following along what I'm doing. All right, I'll see you soon.